We are starting with introduction to machine learning today. So the topics that I'm gonna cover. So we'll understand what is machine learning. We'll understand a technical definition. Along with that, we'll try understanding it with a simple example as well. And then we'll discuss about the different types of ML. Thirdly, we'll discuss about the applications. So after applications, if there is a time, we'll discuss about a regression versus classification. All right. Our very first thing, we'll start with the first topic, which was machine learning. So when it comes to an interview perspective, people can ask you what is machine learning in two different ways. Sometimes people will ask you what is machine learning, straightforward technical definition you can give. Another one, people can also ask you like, can you explain machine learning with a simple example? Or can you explain machine learning to a non-technical stakeholder? Just to know how do you gonna explain what is machine learning to the one who doesn't know anything about it? Okay, so I'll explain both the ways. The first way, I'll give a technical definition and then I'll show you how to explain with a simple scenario. So when I say machine learning, so machine learning is branch of computer science, or usually we say it like a branch of artificial intelligence, which learns from past data or a history and uses that knowledge to make predictions. This is a standard technical definition of your machine learning. Simple. It's a branch of artificial intelligence which learns from past data or a history. Usually, when it comes to a machine learning, there will be an algorithm which will be learning from a past data or a historical data, and based on whatever it has learned, it will be using that knowledge to make a predictions. Just like you don't know anything related to machine learning or an AI/ML, you're studying. Once you study, when somebody asks you a question, you'll be able to answer it. Same goes with a machine learning. First, it will try to learn from a past data or a historical data, and based on what it has learned, that knowledge will be used in order to make a predictions. So that's the technical definition of machine learning. A simple one. Simple wording as well. So now, the next important thing, how do you explain machine learning in a simple way? How to explain ML in simple way. So many times people ask you, like, instead of directly asking what is machine learning, because that's very straightforward, right? People can ask you, can you explain machine learning to a non-technical stakeholder, or can you explain machine learning to the 5-year-old child, right? Because they just want to understand how well you know what is machine learning, how well you people have understood what is machine learning. Okay, so in that case, what you can do, you can try explaining this machine learning using the scenarios. Okay, I'll just take a first scenario, scenario one. So when it comes to scenario one, let's take an example of a father and son. Okay, so we have a father, I'll call like a dad, and this is son. Okay, we have a dad and son. So usually let's consider, son is just like 2 years or 2.5 or 3 years old child. So usually they have an habit of, playing in a park every evening. Just try building a story. Okay. So I'll say father and son. So father and son were playing in a park. Were playing in a park. All of a sudden, the child notices a tree for the first time. You can take other examples as well, like a dog or maybe bicycle, car, something like that. Tree for the first time. Usually, what happens when children sees anything for the first time? Let's say child is seeing a tree for the first time when they were playing in a park. Okay. So initially, children will not be knowing anything. Usual case when children sees anything for the first time, child is curious. When children is or when child is curious, they question a lot, right? Child is curious and question dad and question dad regarding that object or regarding that tree. Okay, what happens now when children question? They don't leave you until you answer that, right? So now it's a responsibility for dad to explain each and everything related to that particular object. So now dad explains each and everything about a tree. Like how does it look like? What is the shape, structure, color? How does it look like, right? So what happened in this entire scenario? Initially, child was knowing nothing. Child was curious, questioned the dad. Now, dad is responsible for answering everything related to that particular object. So, what's happening here? Child is learning something. We call this phase as a training phase. Okay. So, in this case, child learned everything about tree from dad. So we call this phase as training phase. We call this phase as training phase. Hope it's clear. In our machine learning, the first phase is we're gonna train a model or an algorithm with our data. So it's gonna learn things the way the child is learning. We call it like a training phase or a learning phase. This is a scenario one. I hope you got it. So now, once child learns everything related to that particular object, second scenario. So second day, okay, when child sees the same tree or a different tree, when child sees the same tree, now do you think child is curious? Will child question a dad? Next day, when child sees the same tree, next day,
No,
oh,
he will listen.
yeah, child is not curious, no questioning, nothing. Rather, this time, child is able to recognize, or child was able to recognize. Instead of questioning, instead of being surprised, it just recognize, able to recognize the object as tree. It shows like Papa, look there, there is a tree. Or if it looks at a dog, same way. Or maybe the car or a bicycle. You can reframe the scenario according to your requirement. Okay. So in this phase, what's happening here? So previously child learned something, so we call it like a training phase. So now child was able to recognize the object as a tree. We call this phase as testing phase. This phase is called as testing phase as child was able to recognize a tree. Child was able to recognize tree. Understood two different scenarios. First phase is a training, and the second phase. Usually, what happens now? So, the father is responsible for training a tree, right? So, here, so we'll call this as a child. So, what's happening? First, child is learning. So, I'll call it like a learning phase or a training phase. Child is learning something. So, here, tree is basically a data in our case. Right? Information. Data is nothing but an information. Child is learning something from a father. We call it like a data. Training phase. Next time, when child sees a new tree, we call it like a test data. That's a training data. So now the child will be able to make a prediction as tree based on its learning. So we call this phase as testing phase. So this is how the machine learning is going to work. So your ML algorithms, machine learning algorithms are like a child which learns from a past data. Okay. And when new test data is passed, The model will be able to make up predictions. So two phases in machine learning, one is a training phase, another one is a testing phase. This is related to machine learning. What is machine learning? How to explain machine learning with a simple scenario? Clear? Understood? Okay. Any questions you can ask? So now we'll understand what are the real world applications of ML, real world day to day life, like we are using certain applications which uses an machine learning concept, real world applications of ML. Can you list out few examples or applications? Something that learns and based on that it's predicting.
Chat GPT, you can say.
Yeah. We'll start with very basic. First one, YouTube. Any idea how YouTube is using ML? Basically in our YouTube.
YouTube and even Netflix, they are using this algorithm to
Exactly.
like suggest like same if you are watching some
Mm.
kind of genre, so they
Mm.
will recommend you
Right,
best
yeah,
recommendation system.
exactly. So coming to a YouTube, whenever you watch someone's video, so you'll get a similar recommendations. So these are the videos related to that particular person. You get a suggestions. So how YouTube knows that you are interested in that particular topic or that particular person? It's because YouTube has an ML algorithm which is understanding your search history. If search history is off, you don't get a recommendations or a suggestions, right? Video suggestions or recommendations, it's just because of ML algorithm. Coming to a Netflix, let's say you watch one horror movie. Again, it shows you right, these are the movies that are pretty much similar to the movie that you have watched. Again, Netflix is understanding your history and accordingly it is suggesting. Understanding. Next one. Coming to your Amazon or a Flipkart. You know how ML is using in this case? When you plan to purchase something, let's say you are looking for a phone. So along with the phone, whatever other products are related to a phone, everything will be suggested by the Amazon or the Flipkart. We call it like recommendation. Many time it shows you like these are the products which are brought together. Even though you didn't had a plan to buy them, just because it is showing a suggestion, you feel that okay, I should buy along with this particular product. Coming to a LinkedIn, Facebook, Instagram, you get a suggestions, follow suggestions, or reel suggestions just because of an algorithm. Every application has an algorithm which is suggesting things for you based on a history. Sometimes reels will be based on what you have watched. And follow request. Let's say if you're following me, you will get a follow suggestions like okay, these are the people followed by Jivita. Or like these people follow a Jivita so that you can also follow them. Same goes with LinkedIn, same goes with Instagram. And coming to more advanced, whatever AI tools we are using, ChatGPT, Claude AI, right? Gemini model. All this have been learned huge amount of data. So based on its learning, so it is producing new things for you. It generates a new things for you. Understood? So these are the different applications. Anything else apart from this? Google Ads. So whenever you search for something, when you search for any website, usually it will show an ads related to that particular website because you might have visited that site. So that's the reason it is showing suggestions according to that. So these are the different applications of machine learning algorithm. Hope you got it. Okay. So the next important thing we need to understand the different types of ML. So what are the different types of machine learning algorithms we have? Majorly three types. Hmm.
Jivita, can I have a small doubt?
Yes.
Jivita, I have a small doubt. I don't know whether I can ask no or in the future.
It's okay, you can, you can. Do I have a
Because so when I started learning that time, I just used the structured data, means the data which is in Excel. Then I used to feed the model. Then I used to try. So nowadays, so you said YouTube, Netflix. So which type of data they will collect and they will use to train the model? Whether they
see,
structured data or unstructured data?
see, basically, when it comes to a structured data, you expect data which is in a table format, right?
Yeah.
So when it comes to YouTube, so again, like it can be a video or thumbnail suggestions. So it can be a combination of both structured and unstructured.
Okay.
We're just saying like high level applications, like because machine learning is a vast domain, right? Artificial intelligence is vast. Under that, we have a machine learning. Then we have deep learning, NLP, generative AI, and all. So this is major. The overall applications we said. Okay.
Okay. So with the help of videos and images, I can train the model. Right? That's what.
Yes, that's a part of machine learning itself, no? Which is a deep learning,
Okay.
understanding.
Yes.
So AI is like a huge domain. Mute, mute. Okay. So artificial intelligence is like a main domain. In that, we have a vast domain called as a machine learning. So when I say machine learning, it deals only with a structured data. Okay, part of ML is your deep learning, and part of deep learning is NLP, and again part of NLP is generative AI. So whatever applications you see related to Gen AI, NLP, deep learning, so everything will be a part of ML only. Okay, everything is based on machine learning understanding only. Hope you got it.
Oh yes. Now I.
Yeah. All right. So now we'll discuss about the different types of ML. Very important. So types of machine learning. Majorly we have a four, but we do consider only three things. First one is supervised learning, and then we have unsupervised learning, and very important one we have a reinforcement learning. Okay. So these are the major. There is one more semi-supervised. It's just like a combination of supervised and unsupervised but major focus is on these three things: supervised, unsupervised, and reinforcement learning. These are the three different types of machine learning. So now the question is, before I explain what is supervised learning, I just want to discuss about what is labeled and unlabeled data. Okay. Any idea what is labeled data?
Label data, we can say like if we are going to predict the housing price,
Hmm.
so we will collect the data. Like, let's say this is the, like in this region, these are the characteristics of data, and this is the output, like how much it will cost. So
Mm-hmm.
it has output with input as well. So
Okay.
we will train both things. Same like goes like if you are predicting with health insurance. So you know this is like this person has this BMI, this is his age, this is smoker or not smoker, and this is his insurance premium, like that.
Okay. Good. All right. So when I say label data, so usually data is represented something like this: y equals x. Okay. X is basically called as an input, or which is independent variable in this, and y is called as an output. Which is dependent? Which is independent?
Y is dependent on X.
We call it like output, dependent. This is input or independent. So understand, when I say label data, if data has both input and output, we call it like a label data. If data has both input usually we represented as X, input and output, which is Y. If data has both input as well as an output variables, we call it like a label data. Same way, we have a second one which is unlabeled data. So when I say unlabeled data, so here just opposite, data will have only input, no output. But no output. Okay, we call it like an output or a target or dependent variable. So for input, we call it like an input variable, independent variable, or sometimes we call it like a feature as well. Feature. This is output dependent, or we call it like a target. Understood what is labeled data and what is unlabeled data? So now based on this labeled data and unlabeled data, we'll try to understand the types of machine learning. Okay. So coming to the first one, which is supervised learning. Okay. Any idea what is supervised learning? So when I say supervised learning, it's a part of machine learning. It's a type of machine learning which requires a label data. Okay, supervised learning algorithms requires, I'll say it requires labeled data. And you know what is labeled data? Data has both input as well output. Understood? So when I say it requires a label data, that means your algorithm will be trained with both input as well as an output. and then it makes a prediction. Prediction, we call it like a y hat. Clear? For example, let's say you are looking for an house and you want to know what is the price of an house. Usually, what we do, we just search for certain sites, which basically helps us in predicting the price or finding the price of house, or usually we look for a broker. Instead of that, can we build a model which can basically helps us in predicting house price based on certain features? So I'll just call example as house price prediction. When I say house price prediction model, let's say I want to build a model which can help me in predicting the price. So usually in order to purchase a house, like what all factors plays a very important role in predicting price? Obviously square feet, the number of floors, location, even the number of rooms, and finally price. So if data has both input and output data, and if you are using that both input and output to train your model, we call such models as a supervised learning. So tell me, in this, which is input variable and which is output variable?
Price is output and the others are input.
Exactly. So clearly, from a problem statement or a title of a project, you get to know what are you trying to predict. What you are trying to predict is going to be the target. This is a target. Okay, what you will predict is going to be the target or output variable, and remaining are all input variables. I'll call it like x1, x2, x3, x4. There can be multiple inputs, but there should be only one output. Understood what is supervised learning? An algorithm requires both input as well as an output. One more example. In order to know whether a person has diabetic or not, usually we go to a lab, we test it, and we take the report, and then that report has been given to the doctor has studied a medicine, so they know when to say diabetic, when to say non-diabetic. Based on their learning, they analyze the report and they just say whether a person has a diabetic or not. So now, can we build an ML model which can behave like a doctor, who can help us in predicting whether a person has a diabetic or not based on a certain factors? Okay, so let's say, for example, you want to build diabetic prediction model. So, in order to say whether a person is diabetic or non-diabetic, certain factors are important, right? So, BMI is important, age is important, blood pressure, um, I would say insulin,
Glucose level.
yeah, so glucose level, cholesterol, etc., and I'll say result. So, in this case, which is going to be target, which is going to be the input variable. So result is dependent on all these things. So these are all inputs. Yeah, and this is going to be a y, which was a target or output. Clear? Understood? Any questions? This is related to supervised learning. Okay. So next one. Again, the supervised is classified into two things. Okay. Types of supervised learning. Any idea what are the different types of supervised learning?
Classification, regression.
Yes, one is regression, another one is classification. Okay, so it's a regression and a classification. So now what is regression, what is classification can be understood with the help of what type of data your target column is holding. Okay, so before I explain what is regression algorithm, what is classification algorithm, let me explain the different types of data. Okay, so first thing, you know what is continuous data?
Yeah, smooth data, like line chart that can be draw.
Mm,
You can say time series data is a continuous data.
I would say like non-countable or the data which lies within a range, right? Example, a data which lies within certain range or uncountable data. Usually we call it like a continuous data. For example, so one of them is time series, age, height, weight, price, sales, all these things comes under a sales, time, temperature. They're all examples of continuous data. Okay. Data which lies within certain range, usually it's a numerical data. I can also call it like a numerical data which lies within certain range. Okay. So it's a numerical data which lies within certain range here. So the next type of data is categorical data. You know what is categorical data? It's not a numerical data. Categorical data in the sense it's a text data which includes a categories, which includes categories. Examples, or if you have like yes, no, true, false, okay, positive, negative, or maybe diabetic, non-diabetic. So cancer or non-cancerous. So these things usually we call it like a categorical data. Understood?
Binary data, basically, right?
Yeah, it can be binary or multi.
Okay.
It can be like high, average, low. Even that can also be, but it will have like multiple categories. It should be text and different categories: high, average, and I'll say low. All right, next one. So we have a concept called as a discrete data. So what is discrete? Sorry. Discrete. So when I say discrete, they are not continuous. It's a numerical data, but it will have a discrete values, countable values. Okay, so countable numerical values. For example, like if you have 0 1, sorry, yeah, 0 1, coming to our ratings, like whole number ratings, okay, not decimals. What if you have ratings like 0 1 2 3 4 5, like this? If it's a numerical value, instead of true false, it will be like 0 1. Positive, negative, it will be 0 1. So we call that as a discrete data. Okay. I hope it's clear. Continuous means numerical data which lies within certain range. Sales, time, temperature, price, all these things comes under a continuous data. When it comes to a categorical, the text data which includes a categories like yes, no, true, false, positive, negative, diabetic, non-diabetic, cancer, non-cancerous. When I say discrete, it will be like either 0 1 or 0 1 2 3, something like that. So now based on this three different types of data, we'll try understanding what exactly is regression algorithm. Any idea what is regression? So regression algorithms are used when data type of target column is what? So regression algorithms are used when data type of target column, in the sense like your output column, okay? Data type of your target column is continuous. Got it? In such scenario, we're gonna use our regression algorithms. For example, can you give me examples where data type of target is continuous or the variable that you're gonna predict is continuous, then it's a regression.
House price prediction.
Exactly. But first case, house price prediction, predicting price. Insurance price prediction. Okay, sales prediction.
Stock price prediction.
Yeah, good. Loan amount prediction. You can also predict a food delivery time, etc. You can find different applications like this. Clear about regression? If data type of a target column is continuous, if you are going to predict a continuous target variable, then we just use regression algorithms. So you know what are the different algorithms that comes under this?
Linear regression,
Mm.
and I think there are different types of regressions. So
Okay.
What we calling?
So when I say regression algorithms, the very first one you're gonna start with a linear regression. In that you have multilinear and all. So we have ridge, lasso, and also elastic net related to regularization. And then very important one, next one, we have what next? Canon. We have SVM, support vector, regressor. So we'll be discussing all DT, decision tree. We have random forest, RF, regressor only, okay. And then we have gradient boosting. Finally, XGBoost. So these are the different algorithms that basically comes under a regression.
Logistic regression.
It's a classification.
Okay.
So it has a name like a regression, it comes under a classification. Okay, yeah. All right, this is all related to regression. Hope it's clear. So next one. Okay, tell me what is classification? So when I see classification, classification algorithms require data type of target to be either discrete or categorical. If it's a discrete or a categorical, in that case, we're gonna use a classification algorithms. Okay. Examples. So diabetic prediction. So wherein you'll be predicting diabetic or a non-diabetic. Then you have cancer prediction, where you'll have values like cancer or a non-cancerous. Okay. And then we have heart attack risk classification. It can have values like yes or no. Anything else you know? Loan approval. Like yes or no will be there. Loan approval prediction. And then we have customer churn prediction. HR attrition prediction, etc.
What will be example of discrete in this case?
Yeah, I'm coming to that. So coming to a diabetic or a non-diabetic, it can be two values, either diabetic or a non-diabetic. Cancer prediction, you will have a two values, cancerous, non-cancerous. Heart attack risk classification, it can be yes or no. So some data set can have a values like yes, no, or binary values of yes and no is what? 1 and 0. Okay. Again, loan approval, yes or no, or approved, not approved, again 1 0. Customer churn prediction, churn, non churn, or it can be yes or a no. S is always a 1, no is a 0. Getting? Again, for attrition, it will be yes or no only. Hope it's clear. This is all related to regression and a classification. So, what algorithms comes under this? When I say classification algorithm, first one is a logistic. Even though it has a name regression, it comes under a classification. Why? I'll justify when I explain logistic regression. Very important question people ask, though it's a classification problem, why it has a name like a regression? Okay. And then again, the same models can be used in order to solve a classification problem as well. We call it like KNN classifier. Logic will be different. That's it. Naming is same. Support vector machine classifier, decision tree classifier, random forest classifier, gradient boosting, and then we have a XGBoost. Okay, these are the different classifiers we have. This is related to supervised regression and a classification.